Here is the next example. In this example, he's asking about find the current supplied by this 100 volt source by using the source transformation theorem. Okay, we know that from the source transformation theorem, if a current source in parallel with resistor, we can convert this into a voltage source in series with resistor, and vice versa. If you have a voltage source in series with resistor, we can convert that into a current source in parallel with resistor. Okay, in one of the previous videos, by using the superposition theorem, I already found this I1 as negative 0.75 ampere. So we're going to verify it by using the source transformation theorem. Okay, we don't need to worry too much about this number. So now I'm going to label X, Y terminals here. Why am I doing that? Most of the times students get confused. They cut the elements here, but they attach them somewhere else. That is the reason I label them. So that way, once you convert this into a voltage source in series with resistor, we can bring it back and connect it here. So here I have 8 ampere in parallel with 50 ohm. Okay, X and Y. What I can do, I can convert that into a voltage source. The arrowhead is going to be positive, and the arrow tail is going to be negative. The voltage here is 8 times 50, which is 400 volt. Now, and then 50 ohms right there. This is X and that's Y. So it's going to be 400 volt, 50 ohm, and make sure you connect it back at the same point. That's what I did right here. Okay. At the same time, another thing I did, I converted this voltage source in series with resistor into a current source in parallel with resistor. So when I convert this into a current source in parallel with resistor, so I have 30 ohm, 60 volt, terminal A and terminal B. When I convert this, it's going to be 30 ohm and 2 ampere. 60 divided by 30, that will give you 2 ampere. Okay, so I connect it back between the same terminals A and B. Once I connected, I can clearly see these two resistors, 50 ohm and 30 ohm, they are in series. So I combined it, make it as a 80 ohm resistor, and 60 ohm, 30 ohm are in parallel. Okay, so when I combine it, it is 20 ohm. So my final circuit is going to be something like this. Now, what I can do here, I can convert this 20 ohm 2 ampere into a voltage source in series with resistor. So just I'm labeling it as A and B. If I do that, I'm going to have a 20 ohm in series with a 40 volt battery. Now here, that's it, that's the end. I cannot convert any further. Okay, the elements are going to be I will end up with 2 loops. Now I can use the loop analysis or mesh analysis to find the current right there, I. But we will try for, at the end we want to have 1 loop. That's our goal. Okay, so what I'm going to do, instead of converting this 2 ampere 20 ohms, I'm going to keep them as it is, but I'm going to convert the 400 volt 80 ohms into a current source in parallel with resistor. Okay, so the resistance is going to be 80 ohm and current source is going to be 400 divided by 80, 5 ampere. Okay, positive is always arrowhead. Okay, now all these 5 elements exist between the same nodes. Okay, so I have 5, 80 and the voltage source, and then 20 ohm, and then 2 ampere. Okay, so everything is connected right there. So what we can do here, we can shuffle the elements we can shuffle it. So I'm going to move this voltage source to the end, and I'm going to move resistors in between and the current to the end. So what I did, if you look at here, I shuffled everything. So two current sources, I kept them one side, two resistors in the middle, and the voltage source at the end. Now the total current supplied by these two is 5 plus 2 ampere, so I can make that as a one current source of 7 ampere, and 80 parallel with the 20, that is 16 ohm. So 7 ampere, 16 ohm, and voltage source. And now I can convert this 7 ampere 16 ohm into a voltage source in series with resistor. So that's what I did. 7 times 16, 112 volt, 16 ohm, and then here is my X and Y. I'll connect it back. Now my current is, I can use the, this is the current direction. I'm going to say, because this is what he's asking for, I equal to the voltage at this point is 100 volt. The voltage at this point is 112 volt. And I'm assuming this is grounded. So 100 minus 112 divided by 16 will give me minus 0.75 ampere. Okay, this is the source transformation theorem. I'll stop this video here. If possible, I'll solve one or two more examples in the next video. Thank you.